This is the video for your guided notes for lesson 5.2, proportions. In your I can statement at the top of your notes there, you can write I can compare ratios using proportions and the cross products property. I can compare ratios using proportions and the cross products property. In this line here, a proportion, an equation stating that two ratios are equivalent. Which means equal. So a proportion is an equation stating that two ratios are equivalent. Proportional, two quantities that form a proportion. And we'll look at some examples of those. So you look here, example says 2/3 equals 4/6, or the proportion is read 2:3 as 4:6. So you think about, make a recipe for a certain food. If it's 2 parts for one ingredient for every 3 of another, and that means it'd be 4 parts for every 6 as well, depending on the amount of ingredients that you're trying to put in to make for the portion size. Cross products property, when you multiply the numerator in one ratio with the denominator in the other ratio. If the cross products are the same, the ratios are proportional. And we'll see what that looks like here, this next problem. So task 1, determine whether ratios form a proportion. Tell whether 6/4 and 8/12 form a proportion. So one of the ways that we can figure that out is to get each ratio in simplest form. So the 6/4 is improper, but we can go ahead and simplify that by both of them are divisible by 2, and that would give us 3/2 in simplest form. And the other fraction, 8/12, those are both divisible by 4. We divide 8 by 4 and we would get 2, and divide 12 by 4 and we would get 3, so we get 2/3. So we look at 2/3 and we ask ourselves, is that equal to 3/2? And clearly the answer to that is no. So that means that 6/4 and 8/12 do not form a proportion. Determine whether the ratios form a proportion using cross product method. So again, two methods that we'll use here, putting the fractions in simplest form or using the cross products. So if you remember what it said with cross products, it says when you multiply the numerator in one ratio with the denominator in the other, and you're doing that twice. So cross products, so they're diagonals. So the numerator in one fraction, in this case 1, times the denominator in the other fraction, in this case 10. And then you do the same thing with the other diagonals. So the denominator in one fraction times the numerator in the other. So we're going to do 1 times the 10, and we would get 10. And we're going to do 2 times the 5, and we're also going to get 10. And we compare those products. If those products are the same, then those ratios are also equivalent. So we know that 10 equals 10, so 1/2 also equals 5/10. So determine whether the ratios form a proportion. In this case, yes, they do form a proportion. And again, the other method is to put them both in simplest form. We know 1/2 will simplify to 1/2. We know that 5/10, if we divide those both by 5, we would also get 1/2. So they both simplify to the same thing. So two main ways we'll use to see if two ratios form a proportion. Task 3, identify proportional relationships using word problems. Solve using both methods. Simplify the ratio to the simplest form and cross products. So it says you swim your first 4 laps in 2.4 minutes. You complete 16 laps in 12 minutes. Is the number of laps proportional to your time? So they want us to practice both methods here, simplifying it and the cross products. So if we have 4/2.4, we want to know if that is equal to 16/12. Okay, so in both cases, notice that we have laps over minutes, 4 laps over 2.4 minutes, 16 laps over 12 minutes. So there's different ways we can set this proportion up, but we do want to make sure we keep the 4 and the 2.4 together. And if I put laps over minutes, then in the other fraction I would also need laps over minutes. So one of the ways, again, simplifying them both, a little bit of extra work in simplifying that first fraction due to the fact that you have a denominator on the bottom. So we've got 4 over 2.4. And when we simplify, we just don't want to have a decimal as our numerator or our denominator. So one way is simply we want to move that decimal over one place so that it becomes 24. So we have a whole number as our denominator now. So mathematically, what we did to move that one place to the right was we multiplied it by 10. 2.4 times 10 would give us 24. So if I multiplied the bottom number by 10, then I'd have to multiply the top number by 10, which would give me 40. So we're saying 4 over 2.4 is the exact same value as 40 over 24. But now from here you can see that we can simplify this. So now they are both divisible by 8. 40 divided by 8 is 5, and 24 divided by 8 is 3. So we get 5/3, putting it in simplest form. The other fraction is 16 over 12, and we don't have to worry about the decimals there, so we just find what is the largest number that will divide them both, which is 4. And 16 divided by 4 is 4, and 12 divided by 4 is 3, and we compare 5 over 3, and ask ourselves, is that equal to 4 over 3? And clearly 5 over 3 is not the same thing as 4 over 3. So by using the simplifying method, no, these are not proportional. And then the other method they ask us to use is the cross products. So again, 4 over 2.4. We want to know if that is equal to 16 over 12. So again, as long as you keep laps over minutes in each of them, will work out just fine. We do our cross multiplying, so we are doing 4 times 12, and we know that that is 48. And then we do 16 times 2.4. You can use your calculators to help you out on that. You'll get 38.4. So we compare 48 and ask ourselves, is that equal to 38.4? And clearly it is not equal, so also proves that those two ratios are not proportional. Determine if x and y are proportional using a table. So again, in the last lesson, 5.1, we talked about when you write ratios, we always want to have the y on top and the x on the bottom. So if I look at 7 over 1, I want to compare that to 8 over 2. So I can do that by cross multiplying if I want. 1 times 8 is 8, 7 times 2 is 14. 8 does not equal 14. So once I've proven that 2 of those are not proportional, then the whole thing is not proportional. I don't need to do any other testing. If those were proportional, then I would need to still check them with the other 2 ordered pairs, the 3, 9 and the 4, 10. But once I've proven that those 2 are not proportional, then my answer is no. The numbers in that table are not proportional. So now you got some problems to work out on your own. Tell whether the ratios form a proportion. Solve by using the simplifying. So make sure you read these directions right here. It says that you have to simplify them. So for number 1, put both of those fractions in simplest form, and then answer yes or no that they are proportional. Same thing in number 2. Then when you get to number 3 and 4, it says to solve using the cross product method. Again, help if on your paper, go ahead and rewrite them. You're asking yourself, is 1/5 the same as 6 over 30? And then do your cross multiplying from there. Number 5, again, same thing. Just don't forget that the y value should go on top and the x value should go on the bottom. And just if these 2 are proportional, that doesn't mean they all are, so make sure you test all 4 ordered pairs. If the first group, like the one I did, shows that they're not proportional, then you can stop. No need to go on. But if the first two are proportional, then you still need to check that with both of the other two ordered pairs. And then number 6 says tell whether two rates form a proportion. It doesn't say which method that you have to use, so you can use the simplifying method or you can use the cross products. Number 7, you can do 90 sit-ups in 2 minutes. Your friend can do 135 sit-ups in 3 minutes. Do these rates form a proportion? Explain. And most of the explanation is your work in there, and then obviously answering yes or no. And then the exit question, what are 2 ways you can tell that 2 ratios form a proportion? So those are the 2 things that I just got done discussing in the lesson. So do those problems for homework.